Let's review the mixing problems that we began with the chapter 3.2 section. And I'd like to start with the type 1 problem and review it a little bit and then finish it off with the variation we had towards the end of lecture. So recall that we were looking at the concentration of salt in a tank that holds 1,000 liters of water, that there's an input flow of a saline solution, a brine solution coming in at 6 liters per minute, and the amount of salt in that liquid mixture is 0.1 kilograms per liter. That's the concentration. Comes in, and there's a drain, and the solution drains out at the same rate it drains in. And because of that, we assumed that the amount of water remaining into the tank would be constant, and so there would be a constant volume of water and that it would remain equal to 1,000 liters. And that also initially there is pure water in the tank, so there's that no salt concentration. So x of t is the amount of salt in the tank at time t. We assume there's 0. So these mixing models are based on modeling the rate of change of that salt content or any substance in the tank as the difference between an input rate of how much salt's coming in and how much salt is leaving. We were able to derive the equation in terms of dx dt in terms of the input rate by just multiplying the flow rate times the concentration of the salt and got 0.6. And then similarly we were able to determine output rate by using the fact that x of t would be the amount of salt divided by 1,000 liters of water, which is remaining constant. Also making the assumption that the concentration stays the same. And by having done that, we can quickly arise that if the flow rate is 6 liters and x of t over 1,000 would represent the salt concentration, and we can get this term 3x over 500. And solving this separable differential equation, we obtain this solution, which has an exponential form. It's 100 times 1 minus e to the minus 3t over 500. That would tell you what the amount of salt in the tank at any time t is. And then if you wanted to know what the concentration was at a particular time t, then what you needed to do was take that solution and divide it by 1,000. So we're talking about a concentration of that amount of salt in 1,000 liters of water. And that just simply produces a change in this leading constant here. Instead of 100, you'd have 1/10 times 1 minus e to the minus 3t over 500. Okay. So the particular question at hand was, when does the salt concentration become this quantity, 0.05? So what you do is you take this representation of the salt concentration that you're getting at any time t, and then set it to that particular value that we want it to be, and then solve for t. Right? And we can do that here. I didn't go do that explicitly in lecture, but let's just go ahead and do that. So if we're trying to solve for t, then the equation we need to solve is 0.1 times 1 minus e to the minus 3t over 500 is equal to the quantity 0.05. So what we could do is divide both sides by that 0.1, and what we would have is 1 minus e to the minus 3t over 500 is equal to 0.05 over 0.1, which would be the same as 1/2 or 0.5. Right? Then what we could do is realize that we can take this constant on the other side. So we could pull the e term over the right hand side and say, well, that says that e to the minus 3t over 500 is the same thing as 1 minus 0.5, which is 0.5, which also is the same thing as 1/2. So taking the natural logs now, if we take the natural log of e to the minus 3t over 500 equal to the natural log of 0.5, what we would be able to quickly ascertain because of the property of the natural log and E being inverse functions. That means we'd get minus 3t over the quantity 500 is equal to the natural log. Well, we could write it this way. It's the natural log of 1/2 over here, which is also the natural log to the minus 1 power. So we could say this is equal to minus the natural log of 2. So these negative signs would cancel out, and then what we would get is that t is equal to 500 over 3 times the natural log of 2, which will turn out to be about 115.52 minutes. So that's how long it would take to get that particular concentration.